Good morning or good afternoon, depending on where you are in the world. Welcome to today's free educational webinar on optimizing energy savings for grid-connected hybrid systems with the HOMER Grid software. I'm Marilyn Walker, the Chief Operating Officer here at HOMER Energy, and I'm excited to be here with you today, and we really appreciate you showing up. We offer these free educational webinars monthly so that we keep you up to date on what is happening in the world of HOMER and how to best use the HOMER software, our services around the software, and sometimes our close partners who offer products and services that we think add value to you. I'd like to introduce you to the team today. Our main webinar presenter today is Steffi Klawiter, our product manager. She is supported by our Associate Product Manager, Arbi Madhavan, a member of both our product and support teams, and Arbi will be here with us today helping answer the questions. And also Arbi is going to be next month's webinar presenter. So for those of you new to HOMER, it is an acronym for Hybrid Optimization of Multiple Energy Resources. The HOMER approach includes 3 different processes nested together. At its core, HOMER has a simulation engine. It simulates the operation of an electric power system for 1 year, hour by hour, or minute by minute. And at each of these time steps, HOMER looks for the most cost-effective way to meet the electric load based on the set of constraints that the user defines. So simulation tells you how one system operates, and then the optimization step simulates hundreds of different systems to find the least cost system. Finally, HOMER has an option to do sensitivity analysis, which allows you to look at the impact changes in variables that you don't have control over, such as fuel price or wind speed, changes in equipment price, all sorts of things, have on your design and system costs. So asking this question, what matters and when, and letting you see the impact of those variables. So using HOMER to design and optimize your microgrid or distributed hybrid energy system has 3 main steps. First, you provide information on the economics, such as interest rate, with your energy demand profiles, location, which tells us the renewable resources, solar radiation, and wind speed, and then the types of equipment that you wish to consider, shown here as the system components. So you hear us talk about components a lot. HOMER then steps through the 3 nested processes I talked about in the last slide: simulation, optimization, and sensitivity. And then it provides detailed results, not only on the economics of the system, but also on exactly what's going on, literally in every hour, if that's what you need to know, or every minute if you did 1-minute modeling. So we now have 2 versions of HOMER available. HOMER Pro is our original product and remains our flagship, with broad applications for microgrids in many markets. Today, we're focusing on our newest product, HOMER Grid, released just not quite 1 year ago. HOMER Grid was designed explicitly for behind-the-meter systems in grid-connected markets, where demand charge reduction, time of use rates, self-consumptions, incentives, resiliency, or some combination of these are what matters most. We've made some important and major improvements to HOMER Grid since its first release, and so we wanted to take today to walk through, how to work with HOMER Grid in its current improved state. So now I will turn it over to Steffi, who's going to walk us through some examples and show us how to use HOMER Grid.
Great, thanks for the introduction, Marilyn, and once again, welcome to the webinar. Today we'll be talking about HOMER Grid, and the version which was most recently released was version 1.3. Today we'll do a brief introduction about what can HOMER Grid do for you, and then we will build up within the software a quick simple example, and then we'll see the other extreme of more advanced modeling techniques, including how you can consider a different tariff that you'd move to after you implement your distributed generation project, or if your site already has existing PV, and accounting for the value of resilience and reliability within HOMER Grid. And we've improved our features around reliability and resilience in this latest version. So very excited to share that with you. Of course, we'll have questions at the end of the webinar. So as Marilyn mentioned, HOMER Grid is a powerful tool for designing behind-the-meter distributed generation systems. And the value streams that it specifically targets are demand charge reduction, maximizing self-consumption, considering the value of energy arbitrage, and then how can your system provide reliability and resilience to your customer. And so the point of HOMER Grid is to find the most economic system which will balance the energy and the supply and the demand sides. And the core competencies that HOMER Energy has gathered over the decade of serving the microgrid market are really leveraged inside HOMER Grid. So there's some aspects of the software that are similar between the two. And for those of you who are maybe confused or more familiar with HOMER Pro, HOMER Energy offers these two products, HOMER Pro and HOMER Grid. HOMER Pro is the flagship product. It's for island microgrids, for energy access, also known as rural electrification. And it's for unreliable grids where outages are a regular occurrence, or maybe where you're considering whether it makes sense to install distributed generation on site or extend the grid connection. So HOMER Pro has multiple dispatch algorithms which are designed to handle, for example, multiple generators. And there's several other dispatch algorithms in HOMER Pro. There's a wider range of technologies, and HOMER Pro is really a flexible tool with a wide range of applications. And HOMER Grid is for specifically behind-the-meter modeling, really focused on commercial scale solar and storage, and value stacking for the different value streams that I mentioned. And so what we're going to see today within the software is how easy it is to use HOMER Grid quickly. We've tried to make it easy for you to quickly analyze the value streams, including demand charge reduction, with this specific dispatch strategy that HOMER Grid uses. HOMER Grid allows you to completely customize the HOMER model to fit your project, including the ability to define customized components and run sensitivity analyses in order to understand and quantify the risks you're facing. And we are the only tool on the market which can model CHP, and we are incredibly proud of our storage model because it is so detailed and gives you the flexibility to model the battery systems that you may be considering. And we've made every attempt to make it quick and easy to use, including we have downloadable resource and load data. We have connected HOMER Grid with a database of up-to-date accurate tariffs so that you can quickly choose by name if you're in North America, what tariff you're on or what tariff you'd consider moving to. And finally, a library of thousands of components, but also the ability to define your own custom components. So with that, let's look at the HOMER Grid interface, and we'll start the software demonstration. So the first thing you'll see is this welcome screen when you come to HOMER Grid, and that is to help you get started. We have a couple of resources, several resources, which are meant to help you get started quickly. We have the Setup Assistant, which will walk you through kind of the basic minimum inputs that you need. We have a tour, which will point out how to navigate through the software. And we have sample files, which allow you to skip straight to the results and see the power of HOMER Grid without building up a file yourself at the beginning. But we'll skip these options today because I'll be guiding you through. So this is the setup page where you will define your location. And you can either choose by the map or type into the search bar. So we'll do a California example in Santa Barbara. And the point of defining your location is really to quickly be able to pull the resource data. So we have a couple databases for resources, which you can download. Great. Or if you have your own measured resource data or your own preferred database, you of course have the opportunity to upload that data, an annual data for a whole year, into HOMER Grid, and that would be under the Resources tab on the left here. So that has the easy to use concept and also the very detailed customizable product concept. So other than we've defined our location and pulled our resources, we could make some notes about the file that we're about to create. And here's some high-level economics, which we'll leave as defaults, and we can also get to those via the project economics section. So the second thing we'll do is we'll kind of work our way down this list. The second thing we want to do is define the electric load. And we have a couple different options for that. We have, if you have interval data for one whole year, that's fabulous and that's the most accurate. So that's, you can import that data in a number of different formats, and including utility API formats and green button data formats. Otherwise, if you don't have that, if you're doing early stage modeling or if you're just trying to understand what HOMER Grid does, we have these synthetic profiles which can come in handy, and you can change the variability. They're a great way to quickly get a representative load profile. Or we have connected with the OpenAI database for load profiles, and that has 16 different building types across the US, and we've even extrapolated the US climate zones to around the world, so that even if you're not modeling within the US, you can still leverage this great tool to help you get started quickly. So today we'll do a large office in Santa Barbara. And this is the data that we've then pulled in, where you can see morning to evening throughout the year. Where it's an office, so during working hours, there's more electrical demand. And I should mention that you can either navigate through HOMER Grid through this left-hand bar, or you can follow these required changes, breadcrumbs at the bottom. So if you see anything in red, that means that you should really address that before you can go to the results. So it's telling me to add a utility. So I can either click on this or I can go here and add a utility. So as I mentioned, we connected with the Genability database, and we will pull over their tariff information that they offer for my project location, which I defined up front. So we are in SCE territory, and we are on General Time of Use Demand Metered option D. All right, so now we've pulled in our information from Genability, and this is how we can check if the data we've pulled in from Genability is what we expect and accurate. We've done a lot of work around making sure that you understand what data is going into your model, because accuracy is obviously very important for us. So within this consumption tab, you'll be able to see each rate and exactly when that applies, and here's a visualization of when that applies. So you can see this on-peak time is in the summer between, you can hover over or read here, between 12 and 6. And with this, you can really understand exactly what rates are in. And if you wanted to compare that with a PDF of the tariff, you can go to this right-hand side, and there'd be a link to the PDF of the rate. So you can, if you're not already familiar with the rate, you can really fact check that you're modeling everything correctly. And of course, these are just from the utility side, what rates are in the tariff. If you wanted to compare a physical utility bill with what HOMER is predicting, you would go to this tariff bill and model, look at the monthly summary and see whether your January utility bill matches with what it's predicting here. And that's a great baseline, because anything that you're presenting to a customer, you're going to have to really have a good understanding of their baseline energy charges in order to really impress them that the hybrid distributed generation system can reduce charges in the long run. So it's not, if you happen to not be in the United States or North America, We have several resources which allow you to build up a tariff yourself, and there's a simple interface here where you can quickly define a single energy and demand and fixed charge. Or we have a very complex tariff builder, which RB will be talking about more next month, so I hope you can join us for that. Because we really understand that, especially for people modeling outside the US, you need to model these complex tariffs as well and build them up. So that's how we allow you to do that. Now, other than the utility serving the load, I'm going to consider, these are my components that I can choose from. PV, of course, and in HOMER Grid, we have the ability to calculate PV production, or I know that there's tens, I don't know, dozens of PV production modeling tools on the market, and if you have your favorite one of those, that's fine as well, because you can combine the power of Helioscope or PV-Syst or Aurora or whatever you need, and bring that into HOMER Grid or Pro. So with Helioscope, we have an API where you can just input your email address and pull over a project. And we've made specific instructions for PV-Syst or any other generic PV modeling tool. But today we'll just use the HOMER capability, and we will choose this generic flat plate. So with that choice, I've pulled in this cost information. And of course, you're encouraged to customize this and change this in order to best represent your site. This data is from a study by NREL, which may or may not perfectly represent your location. So this cost table is maybe a complex concept, but it represents what is the price per kilowatt if you're installing a small system or a multi-megawatt system. And that's how we define the cost curve, is through this cost table. And you'll notice that the cost is something different than the sizing. So we're not modeling what happens at these sizes. That's used to define the cost. Instead, here's where you can define the sizing. The HOMER Optimizer is great. It's our powerful proven optimization that will help you find the size that's most economic most quickly. Or if you would like to do this a bit more manually, or you have maybe specific inclinations about what sizes are possible, then you could do a size your own option, where you could choose the increments you want, or just doing it a bit more manually to understand. With the HOMER Optimizer, you can set upper limits and lower limits, but we won't do that today. So other than PV, what we would consider in this system is storage. And similar to PV, we have this drop-down, or we have this complete catalog. And the drop-down menu includes some generic components and some partner components, and also what I've defined in my personal user library, all these bold ones. And the complete catalog has much, much more. There's hundreds of batteries in the battery library, thousands of components total between all these different technology types. And the complete catalog allows you to go through, sort and filter by duration or max discharge power, and find maybe the battery that you're looking to model most. Another thing of note here is that our batteries have different models, so different data which defines how they operate in our simulation. And some models define different technologies or different chemistries better than others. So often you'll see that an idealized model in this column will often well describe lithium ion, whereas a kinetic model will often well describe lead acid battery. And the battery model, which is most complex and we're very proud of, is our advanced storage model, this ASM model type here. So that includes rate-dependent losses. It includes temperature dependence on capacity and how temperature affects the calendar life of the battery. So it's our most robust storage model, and we've worked with battery manufacturers both in the process of creating this model and also in the process of getting everyone's battery into our library. Today we'll just use somewhat simplified lithium ion, and you'll notice that this one does not have a cost table, and that's fine. We're just not defining economies of scale in this case. So no matter what size installation you'll have, the cost for this battery will be 550 per kilowatt hour. This is, again, what you should customize to perfectly fit your situation and your project. And similarly, there's the cost world and there's the sizing world. So we can choose the sizes by hand, or we can let the HOMER optimizer find the right size battery. So as I mentioned, if we get lost here, always follow the breadcrumbs at the bottom. It's telling me to add a converter because you'll notice that my battery is not able to serve my load. So I'll click there and add the system converter in with the HOMER optimizer sizing option. So with that, that's really the bare minimum of what you, it's maybe not a bare minimum, but it's a simple system, and we can go straight to the results right now. We could also consider different incentives that may be relevant for our project, or we could consider maybe a CHP project. But for now, I think that's great, and we would go to the results. And this is our cutting edge dispatch strategy. It goes very fast, but for the sake of the webinar, we'll skip straight to the results. So in this case, we had, our load was about 1,500 kilowatt as peak. And here's where we find our optimization results table. So each line in this table is a simulation that's been run. And you might be confused about why are there only 4 simulations, because previously I had bragged about maybe hundreds of simulations that HOMER is able to run. And it does. This is just the categorized view of the results. If you wanted to see the hundreds of simulations, you would go to the overall view, and you'd be able to see everything that the optimizer tried to test. So it tested all these different PV sizes and all these different battery sizes, and it came up with the economics for each of those systems. And this also is a powerful tool because the table by default is sorted on net present cost, and that's how HOMER defines the winning system by default. But maybe some different economics may be more important to you. So you'll notice that the recommended system based on the lowest net present cost is 2.7 megawatts with 600 kilowatt hours of battery. However, maybe I'm interested in how can I really maximize my IRR? And maybe that would be a smaller system. So let's see, in our overall results, we can sort by IRR. And indeed, the highest IRR system is a little bit smaller. So I'm double clicking and we're going to look at the detailed results. So we're doing a deep dive into the details, this little value stream. And you can see the different aspects of this simulation with almost 2 megawatts of PV and almost 400 kilowatt hours of batteries. So here's the cost summary tab displaying over the project lifetime, what's the capital cost, what's the O&M cost, and we have the cash flow. We can have different ways of viewing the cash flow, nominal, discounted, by component type, and this quickly lets you understand what the economics are for this simulation. How does this system compare with the utility-only case? And we can go and there's many more charts under here, so you can really understand how the cash flows are different between this base case of utility only and the case that we're considering. Here's some electrical results. And always interesting is how is the battery operating? So I find this DMAP to be somewhat helpful in understanding what's going on. Generally, we're charging in the day, and then especially during the summer on peak hours, we are discharging as much as we can. So that's how you can check that the dispatch is doing what you would expect it to do. Another way to really get insight into what the dispatch is doing is go to the time series plot. So you'll notice this is the AC primary load. So that's the energy demand we have on site. And then what HOMER Grid does is it goes month by month and it says, okay, what's the best, how can I reduce my monthly demand charges the most? And it's a balance of reducing them completely and being completely off grid, or just continuing to buy electricity from the utility. So those both extremes, and HOMER's optimizer finds the best demand limit month by month, so that with your solar plus storage system, now this is your grid purchases, and that's what you're reliably able to reduce your demand charges because of this optimization, where it's showing month by month, this is where your demand limit should be. And of course, you can get insight into all these different parameters, including state of charge, which is what brought us here. So you can see how the battery is being cycled, how the PV is charging the battery. Everything around that can be viewed within the time series viewer. So once you're happy with a specific simulation, then you can use our simulation report, which will make a report of this specific simulation, which maybe you could use to engage a client, respond to an RFP, anything you need to do. Or we have a separate, a second report, which is the optimization report, which will give a concise summary of these different categorized options. So these two different reports are similar. The optimization report can display multiple simulations, and the simulation report is one for one simulation. I hope that's not too confusing. So with that, I think we've seen the key aspects of HOMER Grid, and I would like to kind of switch gears into maybe some more advanced modeling techniques, which may be interesting to the people who are more familiar with HOMER Grid. So one thing we could do is, what happens if my site actually already has PV? So how would I model that? With many of these components, you can choose multiple tabs. You can make multiple PV components to consider. So with this, you'd make another PV component. I'll make it a generic one again. And in this case, it already exists, so I'm not going to pay anything for it. My capital cost is 0. Replacement cost, O&M per kilowatt is $10 a year, say. And for the sizing, this is where you can say that it's already existing and it's 300 kilowatts. So in every system, it's going to model this 300 kilowatts of PV. And if you had a 0, then it would model with and without, but obviously it already exists. There's no need for a 0. And you could stack up multiple PV components. Actually, you could use multiple PV components to make a test of maybe which direction is the production going to be most advantageous. Should I do a west-facing PV system, east-facing PV system, southern-facing PV system? You could make that in each of these components and just define under this advanced tab exactly which direction they're facing and fix that. So we have many, many PV features which can help you model all these different aspects of PV, including a DC coupled PV system. And similar to adding multiple PVs, you can also add multiple utilities. So in our example, we had one utility, but what if I'm on, now I have a E19, what if I'm on E19 time of use and I'm moving to E19 time of use R? So then you would also be able to stack up multiple utility tariffs and get to the results and consider the hybrid system with a new utility versus the old system. And we'll go straight to the results here. So with existing PV and two utilities, I've got my E19 and E19 time use R. This is what the results would look like. So you have, it doesn't actually, HOMER calculates every combination of utility tariff and component. So you'll just understand that our base case utility tariff and our existing PV is this one. And we're comparing it to the E19 time of use R, and that's this utility. So I'll just hide the ones that are irrelevant, like these two are not relevant to what I'm considering. So now I can easily consider, all right, what's the not option R versus option R plus hybrid system? And you can see these economics compare the two different utility tariffs. So of course you can dive into the details again for them. We'll skip that and move to one of the new features with the latest version of HOMER Grid, which is our ability to model outages. So within the Outages tab here, you can not only define the primary load, which has to be served at all times, but you can define a non-critical load, which only needs to be served when you're connected to the grid. So during normal grid operation, these two loads will be added together. And when the grid is not connected, only the critical load will be served. So the non-critical load has the similar options to the critical load, primary load, where you can import that, and we can try importing. Choose the year from which the data is taken. And you'll be able to see, so this is the primary load, the large office, and this is the non-critical load. And you can scale these so that you can essentially say, for the same load profile, 30% is critical, 70% is non-critical, and that's how you'd be able to set up different requirements for outage scenarios. So how you set up the outages is we have two different types of outages. We have the multi-day outages, which are just disasters. They happen once every many years and for multiple days. So we can say some disaster happens and it takes out the grid for 2 days. You can do more, but it may happen every 15 years. You can either pick a specific date on which this outage should be modeled, or what's new and exciting is that you can choose a random date. So I mentioned the ability for HOMER Grid to help you understand and quantify the risk. And so when an outage happens, exactly when an outage happens, can greatly impact the economics and the system sizing recommendations. And this is how you can understand that risk, is by doing random dates. So we'll do a random date and we'll do a sensitivity analysis on what the impact of a random date is. So I'll do that in the outage settings, and I'll say here we'll do 8 random draws or 16 random draws. So that will test 16 different dates on which our outage occurs. And similarly, for the reliability section, so we've kind of separated these two terms into resilience, which is the days-long outages every several years, and reliability, which are we're calling them the shorter outages that happen once or twice or a couple times a year, and they're for shorter. They're kind of the normal blackouts. And we would say maybe we'll do 3 of them. They last for an hour each time, and there's some variability there. And again, we'll use the random outage settings, the random outage feature here, which we've already defined. So this is one of 16 different combinations which will be tested. So this is how we can go to our results, and it will take a minute to calculate since there are now 16 times as much simulations to be run. But these are the results that we would get. So for these different outage combinations, the sizing which we recommend is going to be different. And you can understand, okay, when do the outages occur where it would recommend a smaller size system? And likely a smaller size system is required when there's when the outages occur in non-critical times. So we can see that, okay, here's when one outage occurs, 6 a.m. Okay, that's not on peak time, so it's maybe less important to have such a big PV system and battery system to serve that. So here's where you can see the range of different system sizes which are recommended, and similarly you go through and consider all the overall values where it calculates the many different PV possibilities and the storage possibilities. So this is how you can identify and quantify what kind of risk, and that should be taken into account when you're proposing a system to your client, is what happens when these variables that we assumed in our inputs are actually changing. And so we can do sensitivity analyses on anything in the software where there's the little ... parentheses symbol. So that's where you can understand the risk of this specific variable. So as I've shown you today, HOMER Grid is an incredibly powerful tool, incredibly robust in its calculations, and it's really one of a kind as far as the storage modeling, CHP, and incentive modeling, tariff modeling. So I hope you can join us next time for the tariffs, and I will turn it back over to Marilyn, who will moderate the Q&A session.
Great, thank you, Steffi. I'm going to leave you actually as the presenter just in case you need to pull anything back up from your presentation. So we have great questions, and I've been taking lots of notes here. So an Arabi might actually help answer some of these. So I'm going to first talk about all the tariff questions that I could find. So does HOMER Grid have tariffs for Canada and Latin America and Mexico specifically?
Yeah, so we use Geneability, which is a third-party database that provides all the tariffs, and we provide tariffs for the US, Canada, and Mexico.
So does it have other Latin American countries or just Mexico?
Oh, just Mexico, but if you'd like to create your own tariff, then you can use our advanced tariff table application.
Okay. Well, there's a lot of something scratchy going on there. Okay, great, thank you. And so how come we no longer do Australian tariffs, which we did when we first launched the product?
So we were supporting Australian tariffs in the very first version of HOMER Grid, but after some feedback from our Australian customers who reported that they were outdated, we pulled them out of the product. We have instead created another tool called the Tariff Builder, where you can build your own tariffs, including time of use, structures, contracted demand, and ratchet rates.
Great, thank you. So a couple questions have come up. I'm not sure, whichever one of you is appropriate there, about speed in HOMER Grid. So rather than saying how to speed it up, because I don't know exactly what people are modeling, maybe if one of you could address what slows things down and what are some kind of best practices for not having really long model runs.
Take that one.
Okay.
Right, so as I'm showing you these 16, 12 different sensitivity cases, sensitivities slow things down. So even though they're very powerful, definitely use them sparingly. If you want to test, different, let's see, discount rates, for example, test like 3, don't test 10 of them here, just test a couple and build on it. So sensitivity analyses really slow things down. A next kind of most problematic, something that slows things down quite a bit are the search spaces. So the HOMER Optimizer is a great tool which efficiently calculates the different sizes. You could not, if you list out 100 different search space options, that's going to be a very slow process. So the optimizer will be preferable to that. And just doing unnecessary combinations maybe of components or too many tariffs. So every time you add another tariff, it creates a whole another set of simulations which have to be run. So using the different components and sensitivity analyses and search space values sparingly will speed up things.
Thanks. How about, how do I see the number of years to recuperate my investment? Where are those results?
Great question. Yes, we've done a simple payback time here. So I'll look at, in our overall, the simple payback time is where you would see that. And you can sort and filter and find what is the fastest way to recoup my investment. And so similar to that, you can use simple payback as a column to tweeze through the results and find a project which is going to meet your payback hurdles or IRR hurdles or whatever you need.
Great. How about modeling multi-year loads in HOMER Grid?
So glad you asked. We don't have that now, but that is what we're currently working on, and that will be available in the next version of HOMER Grid, which will come out mid to end March.
Great. So I can answer this question, actually. People are asking a cost question about cost of the system, the capital costs, and is that included in? Yes, absolutely. The HOMER Grid, both HOMER products are looking at the total cost of your system and all of the financing and economics that you put into that. So absolutely, the net present cost and the levelized cost of energy include that. How about modeling a wind farm or PV farm?
We do have wind within HOMER Grid, as you can see here. And yeah, so you can model wind within HOMER Grid and HOMER Pro, as well as multiple PV components.
Yeah, Steffi, I think the question is really about in front of the meter. So,
okay.
So yeah, about things that are not necessarily attached to a load.
Got it. There are some workarounds. It's not really mainstream or recommended, and so I wouldn't go into the details here. HOMER Grid is designed for behind-the-meter systems. So for front-of-the-meter systems, there are some workarounds that you can use, especially in HOMER Pro, like defining a no-load simulation. But right now, we don't have a specific tool designed for front-of-the-meter projects.
Great. So how do I'm sorry, I just realized we have a couple great tariff questions that I forgot to ask when I was on that. How do I know what my tariff is? Where do I get that information?
You should look at your utility bill. It will certainly say the tariff that you're on.
Okay.
Or contact your utility.
And does Homer Grid support deferrable load?
It does not at this time. Homer Pro does have that capability, and deferrable load would be an interesting concept to add to Homer Grid. But right now you can, there's a couple workarounds which you could use in the meantime, such as using the battery to model deferrable loads. But we don't have that feature explicitly right now.
So maybe this could kind of go into, I know you went over it in the beginning, but what is it that Homer Grid does that can't be done in Homer Pro? Why does it stand out as a product on its own?
It has the ability to model complex tariffs in a much more complex way, which Homer Pro does not have, including contracted demand rates, tiered rates. Both products have time of use capabilities, but Homer Grid's tariff world is so much more deep than Homer Pro's world. And this also is complemented with Homer Grid connects to the Genability tariff database. And that is just a huge source of value to quickly be able to pull the exact tariff that you need by name quickly into your model without having to build up that structure yourself. You have the option to, but you don't have to if you're in North America. Additionally, Homer Grid has incentives. So you can model the ITC, SCHIP, whatever incentives. There's several different ways that you can create a custom incentive, and that can be based on the PV capacity, or based on your investment cost, or based on the production of PV. And similarly for storage, you can create custom incentives for storage. So tariffs, incentives, and then the big one is really the dispatch strategy. Homer Grid has a different dispatch strategy, which is designed to reduce demand charges. Homer Pro has dispatch strategies, but they're not designed to reduce demand charges. And so that's, if demand charges are a key part of the problem you're trying to solve, that's where Homer Grid comes in.
Great, thank you. Could you talk about, I'm not sure what this question means. It said, has generator dispatching been added to Homer Grid? Maybe you understand that question better than me.
Yeah, so there's not at this time the ability to model multiple generators. Unlike storage, where you can add up multiple storage, or PV, where you can add in multiple PV components, right now the generator, you can only choose one. And you can choose, there's still, many possibilities to customize this generator. You can have, this is a fixed capacity generator, but you can also do a generator with the search space. However, you can't add multiple generators into the model, and the dispatch at this time does not handle the dispatch of multiple generators as Homer Pro would.
Great. Okay, I think we can do one more question, and I'm going to combine a couple here so that we get to them. So, a couple questions about costs of outages. So, one is about just talking about how does Homer consider the cost of the outage when it's optimizing that? And actually, I'm not sure about this other question. I'm going to leave it off, but let's just talk about that. How do we model cost of outages, and how does that come into it?
So yeah, that's kind of an advanced question. It's a great question. Also new as of January within Homer Grid is this ability to say, I am going to have a penalty for a capacity shortage. And so you can consider maybe the most economic thing is not building a hybrid system to serve what you think is a critical load. Maybe the most economic option is actually not serving the load during an outage. So if you had a factory and you wanted to decide whether you should install the appropriate storage and solar in order to keep that factory running no matter what, versus the case where you know, the production lines have to shut down, and for some hours you're not able to continue producing. That's an economic hit, and that's how you can use these penalties here to model that economic hit so that HOMER can make a fair comparison of the distributed generation system versus the cost of not being able to keep production running. So this is where you would define this under outages and then outage settings. Great,
thank you. Okay, well, we never seem to have quite enough time to do everything and to get to all the questions that we hope to get to, but we really appreciate that you were here today, and we're going to kind of continue this discussion next month, focusing specifically on tariffs within HOMER Grid, and that's going to be led by Arabi Madhavan, our Associate Product Manager. This webinar is being recorded and it will be available. You will get an email when it is ready to be seen. If you did not get your question answered, please send it in through your sales rep or through our support desk, and we will help you answer that question. And thank you again, and we hope to see you next month.